welcome to lesson number 2. Today we're going to look at the compound interest formula a little bit closer, and we're going to look at a different scenario where the interest is not compounded annually. So in this example, the formula is the same, but the only difference is that the interest and n are defined in different terms, and so they're defined in the terms of the compounding period, which we'll take a look at. So all the other variables still mean the same thing. So a is still the final amount, P is the initial principal or the amount that we invested, I is the interest rate per compounding period, and N is going to be the number of compounding periods that actually occur. So just a reminder, I does not always represent the annual interest rate, so a yearly interest rate. I can also be, or is calculated as the annual interest rate divided by the number of compounding periods that occur per year. And N is not always the number of years. N is calculated as the number of years multiplied by the number of compounding periods per year. Before, what we're looking at were just number of years multiplied by one compounding period. And before, also we were looking at the annual interest rate divided by 1. So 1 compounding period per year. So in class example number 1, if I have the annual rate of interest that is 6% per year, we want to state the interest rate per compounding period and the total number of compounding periods in each case. So if I look at part A, compounded semi-annually for 5 years, I'm going to just make a note of my variables. My interest is 6%. If I divide that by my compounding period, we're dividing this by 2 in this case, if it's semi-annually. So divided by 2, that would be an interest rate of 3%. And the value of N here is 5. So this is happening over 5 years. And if it's being compounded semi-annually, that's happening twice per year. So we're multiplying that by 2, and that would equal a value of 10 for N. Now if we do the same thing, but we compound monthly for 6 years, so my value of I, or my interest rate, is going to change. So 6% compounded monthly. Since there are 12 months per year, 12 months per year, we're going to divide that by 12. And 6 over 12 is going to be 0.5%. The value of N here, again, we were starting off at 6 years. So if we take 6, multiply this by 12 months, the value of N here is going to be equal to 72. Now, if we look at this next example, number 2, we have $3,000 invested for 5 years at an annual interest rate of 7%. Complete the table to calculate the final value of the investment if interest is compounded according to the period of time in the table. So if we have a compounding period that is annually compounded, the number of compounding periods per year would be 1. If we have a semi-annual period, this would be 2 compounding periods. A quarterly compounding period would be 4, and a monthly would be 12. So every month the interest compounds. So the total number of compounding periods, so if we're going 5 years, we just take 5 and we multiply it by the number of compounding periods per year. So 5 times 1, that's just 5. 5 times 2 would be 10. For the quarterly period, we would have 5 times 4, and that would be equal to 20. And for the monthly, we would have 5 times 12, and that would be equal to 60 compounding periods. Now, to determine the interest rate per compounding period, we just take our interest rate of 7%, and we divide it by the compounding period. So 7 divided by 1, we'll have 7%. Semi-annually would be 7 divided by 2, and that's 3.5%. And quarterly, we would have 7 divided by 4. That would be half of this, so that would be 1.75%. And if we're looking at it monthly, that's 7 divided by 12, which if you were to punch this in your calculator, you're going to get 0.583%. Usually you would just input it as this value rather than rounding it. Now, the formula for each of these looks very similar. It's following the same compounding formula. And our initial value in each case is identical, so we're always starting with 3,000 for our initial amounts. Now, the only difference, actually there's a few differences in each case, is the interest rate per compounding period, as well as our compounding period itself, or our value of n. So our interest rate in the annual compound is going to be 1.07, and our value of n was 5 years, and that's just happening annually, so n would equal 5. But for all the other ones, n will not equal 5, and our interest rate is different as well. So this is the interest rate we're going to use. So 1 plus 3.5% would be 1.035, and this would be at a value of n equal to 10. We would have, this next one is 1.0175, and our value of n here is 20. And with this last one, it's 1.00583, and this is to the power of 60. Now, if we were to punch all of these in the calculator, so these 4 different amounts, we're going to end up with $4,207.66. For the semi-annual compounding period, we're going to end up with $4,231.80. For our third, or our quarterly compounding period, we're going to end up with $4,244.33. And with my monthly compounding period, we're ending up with $4,252.88.